The general properties of gas is gas molecules move randomly inside a container. That means they can move in different directions. Secondly, not all the gas molecules have the same speed, which means molecules may have different speed. Some molecules travel faster and the others may travel at a slower speed. Therefore, we say the average kinetic energy of the gas molecule represents the gas temperature, T. Also, gas is compressible, 被壓縮, because there are many spaces inside a gas. Inside a gas, there are lots of spaces around. Also, the force between gas molecules is attractive. That means inside the gas, the molecules are attracted towards each other, even though they move in a random motion. And this attractive force provides the potential energy in a gas. The last point is that gas molecule exerts pressure, 壓力, on the container. Let's look at the origin of gas pressure, 起源, 氣壓嘅起源. Since gas molecules move towards the container wall, when the molecules hit the container wall, they exert force on the wall. And the total force, that means the total force due to all the molecules acting on the container wall, divided by the surface area, force divided by the area, is the gas pressure. There are several assumptions for an ideal gas. Ideal gas means 理想氣體. There are 5 assumptions for an ideal gas. The first one, gas molecules move randomly, 隨機運動. Second, the attractive force between the gas molecule is negligible, 忽略不計. Third, all the collision between the gas molecule and the container wall are elastic collision, 彈性碰撞. Fourth, the time between each collision is much longer than the time duration of a collision. Fifth, the size of gas molecule is negligible. That means we can negate the volume of the gas molecule. For a gas, there are 3 quantities which can be studied. The first one is gas pressure. The second is the gas temperature. The last one is the gas volume. There are altogether 3 gas laws. The first one is to study the relation between pressure and volume, P and V, under the condition that the temperature is constant. Second, to study the relation between gas pressure and temperature, P and T, provided that the volume of the gas remains constant. The last relation is to study the relation between volume and temperature, V and T, provided that the pressure of the gas remains constant. The gas pressure, 氣壓, can be increased by any of the below cases. The first one, by increasing the number of gas molecules, N. Second, we can increase the gas molecule hits the container wall more violently. That means increase the speed of the gas molecule. Thirdly, the gas pressure can be increased by the gas molecule hitting the container wall more frequently. 撞擊嘅頻率相對高。We can use kinetic theory of gases 氣體動力理論 to explain how gas pressure P change with the change of temperature T and volume V. First, when the temperature of a gas increases, the speed or kinetic energy of the gas molecule will increase. Therefore, the gas molecule will hit the container wall more violently and more frequently. As a result, the gas pressure will increase. The second method is when the volume of the container decreases, V decreases, the distance of gas molecules from the container wall will decreases. Distance will decreases. As a result, the gas molecule will hit the container wall more frequently. Therefore, the gas pressure will also increases. The last method is that if we increase the number of gas molecules, then greater number of gas molecule or more gas molecule hit the container wall per second. As a result, the gas pressure will also increases. If N increases, P increases. We can show the process 1, 2, 3 using the diagram. For the first one, originally the molecule travel at this speed. Okay, if the temperature increases, that means the molecule has greater speed. Okay, by the diagram, it means it travels at a greater speed. The arrow is longer. Second, if the volume of the gas decreases, that means the volume of the container decreases. The distance between the molecule and the container wall will decreases. Okay. Lastly, it's very obvious. When number of gas molecule increases, we draw more gas molecule in the container. Okay. In this case, more gas molecule hit the container wall in 1 second. That means the force obviously will increase. Therefore, the pressure will also increases.